Hi, this is Fish and welcome to Fish Picks. So here's the situation. Somewhere along the line, I'd managed to give away or lose the key for this Sparrows Cutaway lock. It would be easy enough, of course, to just gut and repin it, but I thought I'd take this opportunity to play with some new tools and see if I could make a replacement key without disassembling it. Now, I'm not a locksmith or a red team pen tester, and I'm sure there are plenty of elegant workarounds which I'll look forward to reading about in the comments. I know, for example, that many of you may have fingers poised to type "impression the lock" in block capitals followed by several exclamation marks, and this would no doubt be a great solution. And it's a skill I'm hoping to develop over the next few months, but for now, I decided to explore a different solution based on my current skill set and the tools I own. So first, let's break the problem down into two phases. Phase 1, I need to determine the bitting for the missing key, and then phase 2, I need to produce a working key from that information. Now, I happen to know that this lock accommodates a 5-pin Schlage key, which gives me a huge advantage in completing this challenge. To tackle the first phase, knowing this allowed me to use my SC4 Lishi 2-in-1 decoder, which is designed to work in Schlage 5 and 6-pin keyways. And this gives me some great information because this device allows me to pick, but also to determine the precise height of each pin stack, which it translates into the cut needed for each notch of the key. So to pick it, I just needed to open the arm of the decoder and apply light clockwise tension, and then starting at the front of the lock, I could see precisely which stack I was working on by following the horizontal scale, and I could search for any pin that was binding based on the increased resistance I felt. In this case, on the first pass, 1 was springy, as were 2 and 3, but 4 was binding, so I brought that to set, and then returned to the front of the keyway for my next pass. This time 1 and 2 were springy, but pin 3 was binding, so I brought it to the set point. On the third pass, 1 was still springy, but pin 2 was binding, and surprisingly, when I brought this to set, I secured the open. Given that I hadn't set pins 1 or 5, I could assume that these must be particularly long key pins that were holding the driver pins at or close to the shear line already. To test that theory, I rotated the core slightly and applied light downward pressure on each key pin, looking to the small vertical scale to the far right of the decoder, and we can see here that pin 1 is an 8 cut, pin 2 is a 6 cut, pin 3 is a 1 cut, followed by pin 4, which is a 5 cut, and finally we have a deep 8 cut again in the 5th position, which gives me a bitting code of 86158. To achieve phase 2, I now needed a set of space and depth keys for the Schlage keyway. This set, kindly made for me by Martin Newton, consists of 9 keys, each of which has 5 notches, all cut to the same depth, and with the appropriate spacing for this particular kind of lock. So the number 1 key has all 1 cuts, the 2 key has all 2 cuts, and so forth. I intended to use these as a set of master templates to produce the new key. I just needed something capable of making precise notch-shaped cuts, and that's where this Lishi key cutter came into play. This hand-operated tool has a 2-part blade that cuts a symmetrical notch precisely and cleanly, provided the key blank is made from brass or a similarly soft material. So first I clamped the number 8 depth key so that it sat on top of the blank and was well aligned, and then pressing the Lishi blade until it was flush with the first notch, I nipped the key blank, nibbling away at the material rather than trying to cut the notch in one go. This reduced the likelihood of bending the key in the process, and it decreased the amount of pressure I needed to apply each time. I then went on to make the cut for the 5th notch, which you'll remember was at the same depth. Then I substituted the number 8 key for the number 6 and made the notch for the 2nd position. I repeated this step twice more, cutting to the 5 depth for the penultimate notch, and then finally addressing the high cut in the 3rd position. For this number 1 cut, very little material needed to be removed, and it's always best to be a little conservative because we can always remove more, but we can't, of course, add material back onto the blank. So then it should have just been a case of cleaning up the edges of the key with some fine grit sandpaper to take away any burrs or rough edges, and it would be time to test our new key in the lock. Now, depending on the tolerances of the lock, I anticipated that the key might need some fine adjustments to achieve a smooth core rotation, so I had some fine files on hand, and it's a good job I did because initially I got no movement at all. The challenge now, of course, is that I didn't know where the problem lay. And so I searched up the depth specifications for Schlage, and I found this graphic, which I converted to metric so that my Eurocentric brain could make sense of the numbers. And with this information and armed with a set of calipers, I was able to compare the target depths for each cut with the current notches on the key. And it was at this point that I came to appreciate just how accurate you need to be in this process. The differences between cuts is just 0.38 millimeters or 0.015 inches, and it's so easy to create inaccuracies in this somewhat crude approach that I'm using. In most cases, I noticed that my notches were too shallow, and so I needed to take away a little more material, which was at least better than the alternative. Typically, this involved 4 to 6 passes with my Grobet No. 4 round file on each of the 5 notches. And once my caliper readings matched the target depths, I tried the key again, and this time it turned smooth as butter. So there we have it. I was able to arrive at a working key without disassembling the lock by using the tools I had on hand, and it took me about 15 minutes, and would no doubt be even quicker with practice, but the limitations of this approach are obvious. The decoder I used here is not cheap, and it's model specific. While Lishi also provide decoders for the American, Quickset, Master and Best Lock ranges, this would require an even more significant investment, which is why I remain convinced that lock impressioning is a more versatile and cost-effective solution to this kind of problem. I was recently lucky enough to watch Martin impression a Yale keyway from scratch in just a couple of minutes, so impressioning can also be quick, but I was aware that I was witnessing the result of thousands of hours of experience at play. Now, I have now gathered together the tools I need to start to learn how to impression, and I hope to share my experiences in future episodes. But for now, thanks for watching, and until next time, take good care.